Okay, so probability tree diagrams then, intermediate tier and B grade. Now before we start, a bit of prior knowledge that you need to have really. You need to be pretty good at multiplying fractions. You need to be pretty good at just general understanding of fractions, understanding what the numerator and the denominator do and what their purposes are. You need to be good with multiplying decimals, just so basic skills then in order to access these. Now, what I've got here, I've got a past paper question, and I could do this video now for at least an hour going through all the different variations of these questions. However, what I'm going to do, this one, as it's an introduction to it, I'd like to just go through this basic one first, show you a slight variation, and then perhaps talk about what it could be, or what style of question it might be in the GCSEs. It could be something nice like this. However, WJC tend to flip these on their head a bit and make things a little bit more difficult and a different way of thinking instead of the very basic fill in the tree diagram. So, Hannah's going to play one badminton match and one tennis match. The probability that she will win the badminton match is 9 out of 10, and the probability that she will win the tennis match is 2 out of 5. Complete the probability tree diagram. Okay, might seem very basic, but the first thing to do, as I've just done here now, is to read the question. I see all the time people just go straight away and try and fill this in. However, make sure you read the question and really understand what the words are saying. So we've got this very fancy tree diagram, and you can see we've got badminton in the first section and then tennis in the second section. So we're going to try and fill in these blanks. Now you'll see here, there's only two events that can happen. She can either win the badminton match or does not win the badminton match. You'll notice it doesn't say lose, it just says win or does not win. Two possible outcomes. If it's only these two things that can happen, then the probability of this one or this one happening has got to be certain. Now the number we use for certain in probability is 1. But with these fractions, we're dealing with tenths. So how many tenths does it take to make a whole number? It's 10. So the probability of Hannah winning is 9 out of 10. So the probability of it not winning would be 1 out of 10, because both of these add up to make 10 tenths. So look at the second section here then. This is the second match now because it's a tennis match. However, you'll see we've got 4 of these branches. Well, you'll notice that the top 2 are a repeat of the bottom 2, because if we're going on a journey, we could either go Hannah wins and then Hannah does not win, or Hannah wins, or could be Hannah does not win in badminton, but then she could win in tennis, so and then does not win. So we have a couple of different avenues in which we could go down. So looking at these two here now, we're dealing with fifths. Remember, certain event would be 1. So if Hannah win in tennis is 2 fifths, then does not win tennis, it must be 3 fifths. Remember, they both must add up to 1. However, these are exactly the same. So for Hannah to win in tennis would be 2 fifths, does not win would be 3 fifths. We have now filled in a probability tree diagram. We get 2 marks just for doing that by knowing that these have to add up to make 1 on each branch of the tree diagram. So let's look at the question underneath. For another 2 marks. We work out the probability that Hannah will win both matches. So I need to highlight it. Obviously we start on the left, just to win and then win again. So Hannah wins again. I've got 2 fractions I've picked up along that journey. 9 tenths and 2 fifths. Now because we have 2 events happening, we have to multiply these fractions together. So I've got 9 tenths multiplied by 2 fifths. Now obviously I would answer this under here on the A4 piece of paper with the exam. However, just to show you now, I'm going to put it up here so you can see how it's formed together. You'll notice I've used a green pen throughout, so you can see the journey and the path that we've taken. So 9 times 2 is 18, 10 times 5 is 50. So probability that Hannah will win both matches is 18 out of 50. So if she had 50 times and 50 matches, we would assume that she would win 18 of them. And that's the first style of question. Second style looks very similar with the trees. However, you will now see we have decimals. Similar rules though, they both have to add up to make 1. Now I've got Wendy goes to a fun fair. She has 1 go at the hoopla and she has 1 go on the coconut shy. The probability that she wins at hoopla is 0.4 and the probability wins at coconut shy is 0.3. Complete the probability tree diagram. Okay, so again, we've got 2 different outcomes. She either wins or does not win. Remember, they have to equal 1. So if Wendy is winning is 0.4, does not win, must be 0.6. Because 0.4 add 0.6 is 1. Coconut shy, if she wins, it's 0.3. So the probability of her not winning must be 0.7. Similar to the one at the top, these two are exactly the same. Okay, so we've got 2 marks just for doing that. Some of you might look at that and go, oh, well, decimal seems to be a little bit easier. Okay, some people prefer using decimals to fractions, and some people using fractions, but work out the probability that Wendy wins at hoopla and also wins at coconut shy. So, highlighter, wins at hoopla and wins at coconut shy. Brilliant. So I've now got these 2 events here, 0.4 and 0.3. So I need to multiply these together. 0.4 times 0.3, 0.12. 4 times 3 is 12. Count my decimal places, I've got 2, so therefore I've got to have 2 in my answer. Right, those are 2 very simple probability tree diagrams. 4 marks for each. Now let's talk about different variations. It could be, work out the probability that Wendy wins either at the hoopla or the coconut shy. So if it's win at the hoopla and then not at the coconut shy, or it could be does not win but then wins here. So she's won once. So Wendy winning once, she'll have to lose or does not win the second time, or she would win the first time, does not win the first time and then win. So these things here, she has won only once. So we could have 0.4 times 0.7. And we could also have 0.6 times 0.3. That's 0.28. This one's 0.18. Okay, I'll put it underneath here to make it a bit clearer for you. 0.28 and 0.18. Obviously, if this was the question, I would answer it underneath here. So this question would be if she must win only once, so she could win and then does not win, or not win and then win. We've got 2 answers. So if we have those 2 answers, we would have to add them together. 0.28 and 0.18. Add them together to get 0.46. So the probability of her winning only once would be 0.46. So be careful with the question. As I say, these have been quite straightforward. You may have variations of where, as I say here, could win only once. So you have to work out which avenues you have to take to see where she only wins once. When you've got 2 of the answers, you have to add them together. What I have seen with WJC is they will have this part would be a decimal, this part would be a fraction. So my advice to you would be to convert them to be the same, and then it makes the multiplication a lot easier. What they also have, they might give you a statement up here saying that the probability of, they won't give you this, and they would say the probability of Wendy winning at Hoopla and Coconut Shy is 0.12, and then you've got to use that information to calculate this one, then follow the tree diagram. So be careful, there are a lot of different variations. So I know there's a lot of information there. Hopefully that's made a bit of sense. You might want to write down a few things, especially this, they're both adding up to make one, and then be careful with how many different avenues you could take to get your correct answer. Hope it helps.